Hello class, today we're going to look at determining whether the pair of functions are inverses of each other. So I am in the study plan, section 10.1, number 31, and we have two functions, f of x equals 6 over x minus 4, and g of x equals 6 over x and plus 4. So the way we're going to determine whether these pair of functions are inverses of each other is we're going to use f of g of x, which means I'm going to take the g of x function, which is the 6 over x plus 4, and I'm going to plug it into the f of x function. Then I'm going to do the g of f of x, which is just the opposite. I'm going to take this 6 over x minus 4, I'm going to plug it into my g function for x and simplify it. Now what I'm hoping for is that both of these, f of g of x and g of f of x, both reduce down to an x. If they reduce down to 3x plus 7 or minus 2, that means that they're not inverses. But if they both reduce down to just an x, then we can say that they are inverses of each other. So the first part is to find f of g of x. So let's go ahead and look at how to do that. So part A is we want to find f of g of x. Again, what that means is I'm going to take g of x and I'm going to plug it into f. So I'm going to take this g of x and I'm going to plug it in to my f of x function. So let me show you what that looks like. So we have 6 over, instead of x, I'm plugging in the g of x function. So I'm going to have the g of x here, which is 6 over x plus 4. And then all I did was replace the x, so I still have the minus 4 here. Okay, so f of g of x means take the g of x, plug it into the f of x. Now I'm hoping that after I reduce all of this, it reduces to just an x. So let's see what happens. Well, plus 4 and minus 4, I can go ahead and cancel those out. That gives me a 0. So I'm left with 6 over x. So we're really working with fractions here. Remember, 6 can really be 6 over 1. So instead of dividing two fractions, I'm going to keep the numerator of 6 over 1 times the reciprocal. So x over 6. Remember, all we're doing is we're changing this division into multiplication by flipping the bottom, taking the reciprocal. Well, notice your 6's will reduce now, and we're left with 1 times x and 1 times 1, or just x. So this is what we're looking for. We're hoping that both of these will reduce to just x. So let's go ahead and plug in our answer for part A, and then see what part B wants. So we determine that f of g of x reduced to an x. Check answer. Excellent. Part B now wants us to find g of f of x. So now we're taking the f of x function and I'm going to plug it into the g function. So let's go ahead and look at that. So part B, we have g of f of x. So now what this means is we're working the opposite direction. We're going to take the f function and I'm going to drop it in to the g function. Okay. So we have our g function is 6 over, we have the plus 4 and back. Now instead of x here, I'm going to plug in my f of x function. So let's go ahead and use blue for that. So we end up with 6 over x minus 4. So I taken the f of x function, the blue one, plugged it into g of x for the x term. And now it's just simplifying. So again, we're working with division. This could be 6 over 1 divided by 6 over x minus 4. So we're dividing fractions. So we're going to change that to multiplication. So go ahead and switch. So we're going to keep the 6 over 1. Now I'm going to take this bottom part and make it x minus 4 over 6. We still have this plus 4 in the back. And since we're undoing division by flipping and multiplying, we should have multiplication there. Order of operations says before we do anything with the plus 4, we want to go ahead and reduce the multiplication. I notice that I have a 6 and a 6. That reduces. 1 times x minus 4 leaves me with x minus 4. 1 times 1 leaves me with 1. I'm not going to write the denominator 1. But notice we still have the plus 4 here. Minus 4 plus 4 gives me just x. So that's what we're looking for as well. So we're hoping that f of g of x reduces to x. So f of g of x reduces the x. And, so this is an and statement. Both of these have to be true. And g of x f of x equals x, then we can say that these two are inverses of each other. So we've proven that, yes, they are inverses. So f of g of x equals x, and g of f of x equals x, then yes, they are inverses of each other. So let's go back to Math Excel. So we found that g of f of x was x. We're going to check that. Fantastic. Now, we have a choice of f and g are inverses of each other. F and g are not inverses of each other. Well, since again we found x for both of these, they are considered inverses of each other. So check our answer, and good job. So that's working with determining whether a pair of functions are inverses of each other. You can use the f of g of x and the g of f of x to determine that. Hope this was helpful.